Welcome back. Problem 2, section 7.3. Fawns between 1 and 5 months old in Mesa Verde National Park have a body weight that is approximately normally distributed. Now that's important information. With mean mu 25.02. Mean mu is 25.02 kilograms. And standard deviation sigma is 4.65. Oops, that's not mean. Mean mu is 25.02 and standard deviation is 4.65. Okay, let x be the weight of a fawn in kilogram. What is the probability that for a fawn chosen at random, x is less than 29.02? So A part is asking us to find probability that x is less than 29.02. So less than is that symbol. All right. Now you need to use a table, but there are no x tables. X is called raw score. You want to standardize it. So that's the formula for standardizing. So at this point, let me standardize it using our mu. Our mu is 25.02. Our sigma is 4.65. All right. So I'm going to use that to standardize this. So let's get going here. So I'm told that x is less than 29.02. So why don't I use this formula to standardize x and standardize 29.02. Okay, so that's distracting. So I have written that expression here. I'm going to write that expression again. This had x, so x continues. This has 29.02. I'm going to standardize 29.02. All right. So this expression is equal z. So I have a z here. And I want z to be less than whatever this be, right? So let's calculate using a calculator. Parenthesis divided by 4.65. What goes inside the parenthesis? Well, 29.02 minus 25.02. I hope I have the numbers correctly. 29.02, 25.02. Okay, good. So that's the amount standardized score for Z. All right. So look, we are going to look at 2 digits after decimal point. 8, 6, the following one is 0. So I don't need to write the rest. So this is same as probability Z less than 0.86. Okay. So we are looking for left area 0.086 using our table. Now with Z score, we are able to use the table. So 0.86, right? I need a 6.8, column 6. 6 is here, 0.8 is here, 0.8051, 0.8051. All right. The next part is x greater than something, right? So let's write that down. So this was A part. Now here is B part. You're looking for probability x greater than 17.53. Okay. So again, you need Z score greater than something, right? So the same situation we are at. I have x greater than 17.53. So I will use this expression and apply it for x, okay? And now greater than, apply it for 17.53, okay? So this fetches me, all of this is a z greater than, let's figure out what this is. So 17.53 minus all of this, right? So I get here. So notice again 2 digits. 1 is 0. So I just need to keep it at 1. So this is negative 1.61. All right. Now, if you see in this fashion, right hand area is 1 minus left area. Why do I make this? Because left area I have a table for it. Okay. So it is 1 minus left area for negative 1.61. Negative 1.61. Let's look for the column there. Negative 1.61 is 0.0537. 0.0537. So that's the amount I need to plug it in. 1 minus 0.0537. Okay, I could use the calculator and find, or I could write this expression. The C part says x should lie between, okay, x should lie between 31.89 and 35.26. All right. So this means I need to standardize it with z in between two numbers. All right. So let's figure this one out. So I will rewrite this expression below, right? And I will use my z formula here. Okay. I will use my z formula 3 times, once here, once here, once here. So the first one is with 31.89 less equals. The second one is simply with the x, and third one is with 35.26. Okay, so we need to find these endpoints. Calculator. So instead of 17.53, I have now 31.89. Everything else is the same. That fetches me this number for the first number. Less equals. This expression is the standard score z value. And this one I need to calculate with the 35.26. which fetches me all of this. Okay, so now let's look at it. 1.477. So I'll make it 1.48. Less equals z less equals 2.202. So I'll make it 2.20. All right. So mind you, here it depends on what approximation web work takes. But let's figure out area between two numbers, area corresponding to the bigger number minus area corresponding to the smaller number. So 2.20 is the bigger number. 2.20. 0 is just the very first column. 2.20, 0.9861. Subtract 1.48, 1.48. 8 is here. 1.48, 0.9306. Okay, so I'll write those two numbers. 0.9861 minus 0.9306. I hope everything is okay. That's it. All right. So next problem, I'll continue on the next video.